So if you remember in the last class, we have discussed some enthalpies: standard enthalpy of reaction, standard enthalpy of combustion, and standard enthalpy of formation, right? So this is your homework question for today, that you have to identify each of the following reactions as standard enthalpy of reaction, standard enthalpy of formation, and standard enthalpy of combustion. One reaction may be more than two enthalpies, so take a screenshot of it, practice it at home. Now next enthalpy which we are going to learn is standard enthalpy of neutralization. Standard enthalpy of neutralization. Okay, so here, as you know the symbol, the delta means change, H means enthalpy, this symbol means standard, and this is the neutralization. So it is an enthalpy change when 1 mole of water it is formed by the reaction of an acid with an alkali under the standard conditions. You know what are the standard conditions. For example, your acid, it reacts with base to give salt and water. So it is exothermic. You can see it is exothermic. Heat is released. For any acid alkali equation, if you want to write down the ionic equation, so you remove the spectator ions. For example, in HCl, you remove the Cl ion. In NaOH, remove the Na ion, and you get the ionic equation as H plus OH minus gives you water. Okay, so this is your standard enthalpy change of neutralization. Write it down.
Done.
Okay, now next topic is bond energies and enthalpy changes. So you have to remember in numerical it is very important to remember that bond breaking. If you break the bond, then energy is required. So it is endothermic process. But if the bond is formed, then energy is released. So it is an exothermic process. So enthalpy changes are due to the breaking and forming of bonds. Breaking bond requires energy, and the energy, what is bond energy? Energy is needed to overcome the attractive forces joining the atoms together when you are breaking the bonds. But when you are forming the bonds, then energy is released. So remember that bonds breaking is endothermic and bonds making is exothermic. That means you have to take the value of delta H as positive in bond breaking and delta H as negative in bond making.
Done.
Chemical reaction, if the energy needed to break bonds is less than the energy released when new bonds are formed, so the reaction will release energy and it is exothermic. And if the energy needed to break bonds is more than the energy released when new bonds are formed, the energy for breaking is more. That means the reaction will absorb energy and it is endothermic. Okay. Write it down.
I'm done.
What is bond energy? Amount of energy needed to break a specific covalent bond is called the bond dissociation energy. We sometimes call this exact bond energy or bond energy. The amount of energy which is needed to break a specific covalent bond, it is called the bond energy. Here, you can see here, this is the reaction pathway diagram. So first one is the energy level diagram, which shows bond breaking and bond forming for the combustion of methane. It is your exothermic process. In exothermic process, your enthalpy of products are higher, right? So this is the energy of reactants and this is the energy of products in the exothermic reaction. So this is nothing. This CH4, it reacts with O2 to give you what? To give CO2 plus H2. Sorry, in the exothermic reaction, you calculate how delta H is equal to HP minus HR. In exothermic reaction, delta H should always be negative. Okay, so enthalpy of products should be smaller than enthalpy of reactants. So this is enthalpy of products and this is your enthalpy of reactants. So this is CO2 plus H2O. So you can see here that these bonds are breaking, so energy is required. And these bonds are forming, so energy is released. Similarly, in the endothermic reaction, for the decomposition of HBr, so in this case, HBr decomposes. This is your enthalpy of reactants and this is your enthalpy of products, H2 plus Br. So energy is absorbed in breaking the bonds and energy is released in forming the bonds. So the energy released is shown by a downward arrow and energy absorbed is shown by an upward arrow. Okay, and this is the intermediates, basically that when 2HBr, when you are breaking the bonds, so you are breaking 2H and 2Br bonds. So you get H2 plus Br2 in this case. So this is your decomposition reaction. Okay, so draw it.
I'm done writing.
When oxygen atoms combine together to form O2 molecule, then the energy released is minus 498 kilojoules per mole. But when this opposite process occurs, when O2 breaks to form two oxygen atoms, then energy is absorbed and it is 498 kilojoules per mole. Okay. So now what is average bond energy? And this is also one important concept of average bond energy. That bond energy is affected by other atoms in the molecule. For example, OH bond in water. Water is made like this, H2O. So this OH bond in water, it has a slightly different bond energy value to the OH bond in ethanol. Ethanol is C2H5OH. So this is also an OH bond. This is also an OH bond. But their bond enthalpy energy values are different in both the OH bonds. In ethanol, oxygen is connected to a carbon atom rather than another hydrogen atom.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Okay, this OH bond is connected to hydrogen atom. This OH bond is connected to the carbon atom. When you make the displaced formula, you got that the carbon is connected to the oxygen atom. We call these bond energies exact bond energy. The OH bond is in a different environment. Identical bonds in molecules with two or more types of bond have different bond energies when we measure them. So it takes more energy to break the first OH bond in water than to break the second. For these reasons, we use average bond energy taken from a number of bonds of the same type but in different environments. Okay, write down the concept of average bond energy. So why it is called average bond energy? Because it is the average amount of energy which is needed to break 1 mole of a specific type of bond, in this case OH bond. Okay, when it exists in different molecules. Now next enthalpy is standard enthalpy of atomization. So standard enthalpy of atomization, it is the enthalpy change when 1 mole of gaseous atoms is formed from its element under the standard conditions. When 1 mole of gaseous atoms are formed, for example NH3, okay, NH3 is taken in the gaseous state, and when 1 mole of gaseous atoms are formed, and nitrogen atoms in the gaseous state and hydrogen atoms in the gaseous state. So this enthalpy is known as enthalpy of atomization. This should be 1 mole of gaseous atoms. This is formed from its element under the standard condition. This 3 is for balancing. Write down.
I'm done.
So this is a numerical how to calculate enthalpy changes using bond energies. Okay. So this is the question that nitrogen reacts with hydrogen to form ammonia gas. Enthalpy cycle for this reaction is given to you. Write it down. That means energy required to break nitrogen bond is 945. Required to break hydrogen 1H2 bond is 436. And to form NH bond is 391.
I'm done.
Done?
Yes.
See, you have to first of all make the structure like N2 plus 3H2 gives you 2NH3. So you have to break N2, 1 this bond, 3H2, and then 2NH3. Okay. So bonds broken, you have to break N2 bond. Okay, that means 1 multiplied by its energy, it becomes 945. Then you have to break 3 into H2. So you have to multiply 3 with the 1 H2 bond energy of 1 H2. It becomes this. You add them, you get this. This is a bond broken. You have to make this table always when you are forming these type of questions. Then you have to make bonds form. So you are forming 2 NH3, right? So there are how many NH bonds? 1, 2, 3 NH bonds are there. So you have to multiply it with 2. 3 into 2 is 6. So 6 NH bond, you have to multiply 6 with the E91. Solve it, you get minus 2346. Why minus? Because bond formation is exothermic or endothermic?
Endothermic.
Endothermic. That means that means delta H2 should be negative. Now in these calculations, one triple bond in nitrogen is broken. N2 you are breaking, 3 single bonds in hydrogen are broken. Okay. That means you are providing the energy, that's why it is positive. Now in bond formation, 6 single NH bonds in hydrogen are formed. So it is bond forming. When you are forming the bond, energy is released, so it is negative sign. The values for bond breaking are positive as these are endothermic, and bond forming are negative because they are exothermic. Energy is released. Then you have to do just add both these enthalpy, delta H1 plus delta H2. Enthalpy change for bonds broken, enthalpy change for bond form. Then you get the value of enthalpy change for the reaction. Is it clear?
Yes.
Write it down.
I think the answer would be D.
What?
Yeah.
4 pH bonds and 2 bonds are broken, and 2 CO bonds and 2 OH bonds are formed. 2 H2O. H2O is H2O. So there are 2 OH bonds, 1, 2, but you have to multiply it with 2. Okay, so that means there are 4 OH bonds. So there is 2 here, so I have to multiply it with 2. This is not correct. Which should be correct?
B.
B, right?
Yes.
Yes, option number B is correct. Okay, so very good.